Hello, everyone. I continue to discuss fintech applications. And in this video, I'll be talking about artificial intelligence and machine learning. Artificial intelligence, put simply, can parse vast databases through advanced algorithms to derive patterns used to predict behavior and prices, and in the end, mimic human judgment in automated decisions. Artificial intelligence essentially are computer systems and they're capable of performing tasks that have traditionally required human intelligence. So AI technology has enabled the development of computer systems that exhibit cognitive and decision-making ability comparable or superior to that of human beings. An early example of AI was the expert system, a type of computer programming that attempted to simulate the knowledge base and analytical abilities of human experts in a specific problem-solving context. This was often accomplished through the use of if-then rules. By the late 1990s, faster networks and more powerful processors enabled AI to be deployed in logistics, data mining, financial analysis, medical diagnosis, and in other areas. Particularly with regard to finance, AI is now increasingly used in automated credit approvals or advice, in facilitating regulatory compliance and fraud detection, and as I just mentioned, automated trading of financial assets. Machine learning, a subcategory of artificial intelligence. Machine learning is a method of teaching computers to parse data, learn from it, and then make a determination or prediction regarding new data. So machine learning involves computer-based techniques that seek to extract knowledge from large amounts of data without making any assumption on the data's underlying probability distribution. The goal of machine learning algorithms is to automate decision-making process by generalizing or learning from known examples to determine an underlying structure in the data. The emphasis on the ability of the algorithm to generate a structure or predictions without any help from human. Simply put, machine learning algorithm aims to find the pattern and apply the pattern. In machine learning, the computer algorithm is given inputs, a set of variables or databases, and may be given outputs, a target data. The algorithm learns from the data provided how best to model inputs to outputs if provided, or how to identify or describe underlying data structure if no outputs are given. Training occurs as the algorithm identifies relationship in the data and uses that information to refine its learning process. Machine learning involves splitting the dataset into three distinct subsets: a training dataset, a validation dataset, and a test dataset. The training dataset allows the algorithm to identify relationships between inputs and outputs based on historical patterns in the data. These relationships are then validated and the model tuned using the validation dataset. The test dataset is used to test the model's ability to predict well on new data. Once an algorithm has been trained, validated, and tested, machine learning model can be used to predict outcomes based on other datasets. Note that machine learning still requires human judgment in understanding the underlying data and selecting the appropriate techniques for data analysis. Before they can be used, the data must be clean and free of biases and is pure as data. So as noted, machine learning models also require sufficient large amount of data and may not perform well where there may not be enough available data to train and validate the model. Machine learning approaches can help identify relationship between variables, detect patterns or trends, and create a structure from data, including data classifications. Machine learning can be broadly divided into three distinct classes of techniques: supervised learning, unsupervised learning, and deep learning. In supervised learning, computers learn to model relationships based on level training data. In supervised learning, inputs and outputs are leveled or identified for the algorithm. After learning how best to model relationships for the level data, the trained algorithms are used to model or predict outcomes for new datasets. Trying to identify the best signal or variable to forecast future returns on a stock, or trying to predict whether local stock market performance will up or down or flat during the next business day, are problems that may be approached using supervised learning techniques. In unsupervised learning, computers are not given level data. Instead, are only given data from which the algorithm seeks to describe the data and their structure. Trying to group companies into peer groups based on their characteristics rather than using a standard sector or country grouping is a problem that may be approached using unsupervised learning techniques. Underlying AI advances have been key developments relating to neural networks. In deep learning, computers use neural networks, often with many hidden layers, to perform multi-stage nonlinear data processing to identify patterns. Deep learning may use supervised or unsupervised machine learning approaches. By taking a layered or multi-stage approach to data analysis, deep learning develops an understanding of simple concepts that informs analysis of more complex concepts. So that's the end of this video where we talked about artificial intelligence and machine learning. In the next video, I will be talking about robo-advisors. Thank you very much.